Hello, my name is Stella Rockwood and my molecule is ampicillin C16H19N3O4S. This is my molecular diary entry number 3. I'm going to be talking about intermolecular forces and how that relates to melting and boiling points, and then I'm going to talk about the acidity and basicity of my molecule. To start out, the most dominant intermolecular force would be hydrogen bonding, and that only happens between a couple different atoms, hydrogen and a couple different atoms. So in this case, it would be the N and then the H, and then we've got oxygen and hydrogen. The next would be dipole-dipole, and that is when there's a partially negative charge and a partially positive charge on atoms. So this sulfur here would have a partially negative charge and it would attract to a partially positive charge on hydrogen. The next would be dispersion forces, and that is a temporary shift in electrons between nonpolar bonds. So in that case, it would be carbon-carbon bonds, it could be carbon-hydrogen bonds, and then there's a carbon-sulfur bond here that's also nonpolar. So as far as melting and boiling points go, we would expect, because it's got such strong intermolecular forces, like the hydrogen bonding is very strong, we would expect that there would be a high melting point and a high boiling point, which matches the research that I did. The melting point of this molecule is 471 degrees Kelvin, and the boiling point is 965 degrees Kelvin. As far as acidity and basicity goes, this molecule is an acid, and pHs have been found to be between 3.5 and 5.5. So it's going to behave as an acid and donate a proton, being hydrogen. And on this molecule, we have an acidic portion, which would be the carboxylic acid, but we also have a basic portion, which would be this NH2, so it would act as a base, accepting a proton. So overall, this molecule is amphiprotic. And that is all for my molecular diary entry number 3.